snakes. One more. Back one more. Back one more. No. Go forward one more. Sorry. Oh, well, that's okay. That's good. All right. So the African snake eagle is a snake-eating specialist. Compare it with the African fish eagle, which is not. These are closely related raptors, and yet the African snake eagle has larger eyes than the African fish eagle. Now, in birds and mammals in general, the larger the eye, the greater the visual acuity, all else being equal. If you're not convinced by that, go to South America and look at the South American laughing falcon. It too is a snake-eating specialist, and it too is described in the field guides as having obviously large eyes and head. The head large to house those large eyes. So like raptors, raptors have variation in their vision, and so do primates. And it turns out that this variation corresponds with how much time primates have spent in evolutionary coexistence with venomous snakes. Venomous snakes arose about 60 million years ago in Africa or Asia. But by that time, the prosimians on Madagascar, the lemurs, had already been there. And so, to this day, the lemurs on Madagascar have never had to deal with venomous snakes. And their visual systems are the simplest among all the primates. For example, they don't have a fovea, which allows them to focus on fine details. At the other extreme are the catarrhines, the old world monkeys, apes, and humans. Like venomous snakes, they also appeared in Africa or Asia about 60 million years ago. And so they have had to deal with venomous snakes for their entire evolutionary history. I should say the ancestors of catarrhines. And not surprisingly, at least in my mind, they have the best vision of all, and the most uniform. For example, take color vision. All of the species that have been studied are uniformly trichromatic. That is, that all individuals can distinguish reds from greens. Now, intermediate between the prosimians and the catarrhines, the old world monkeys and apes, are the platyrrhines, the new world monkeys. New world monkeys actually started out in Africa, and so they had some time with venomous snakes. But about 30 million years ago, they dispersed to South America. And when they got to South America, there were no venomous snakes there. Venomous snakes got to South America between 20 and 3 million years ago. But by that time, the New World monkeys had started to diversify. And what do you do when you start diversifying in the absence of a selective pressure that had been operating on you in the past? Well, you're free to experiment, perhaps without consequences, negative consequences. And what we see today is greater variation in the visual systems of the New World monkeys than in the Old World monkeys and apes. Taking color vision again, howler monkeys, which live in Central and South America, are uniformly trichromatic. They're just like the Old World monkeys and apes. In other species that have been studied, that's not the case. All males are dichromatic, that is, they're red-green colorblind. And some females are dichromatic. And some females are trichromatic. They can distinguish reds from greens, so there's more variation there. And this is paralleled by differences in behavior. If you show if you show a lemur, a snake, or a snake model, it may not act as if it's seen it. It may even walk on it as if it's a branch. But Old World monkeys are well known for their strong reactions to snakes. For instance, here are vervets standing bipedally and giving alarm calls to a python. And these are rhesus macaques at the Primate Center in Davis. Their ancestors started out in Asia. These ones have been captive born and raised. To the best of anyone's knowledge, they've never been harmed by a snake in their lives. But along comes a harmless gopher snake, and they react with what I would describe as fearful fascination to that snake. And when the snake went through the enclosure, these monkeys parted as if they were the Red Sea parting for Moses. Okay, so what I'm suggesting is that snakes were responsible ultimately for primate origins through visual expansion. Now I want to talk about snakes and what they did more closer to home. There are consequences of becoming bipedal, standing upright. One of them is that our eyes are farther off the ground, making it more difficult to see snakes that are already cryptic to begin with. I don't know how many of you can see the object that's in that picture there. Perhaps if I point to it. Can you see it better? I hope so. Because the next thing I want to say is one of the solutions that hominins might have come up with to detect predators or snakes better is to start pointing at them, to direct attention to them. And it turns out that we're highly sensitive to pointing. For instance, we react automatically. When somebody points, we automatically look in the direction that they're pointing in. And this is not surprising to me because there's neural overlap in those parts of the brain that are involved in attention, automatic eye movement, and pointing. This taps into that ancient vertebrate visual system that old world fruit bats converged on with primates. It turns out, too, that our reaction times are faster when others point down and at the periphery. And this is exactly where our hominin ancestors would have found snakes and would have missed them, perhaps, if they hadn't been looking to their sides. Okay, so pointing to direct attention is apparently a uniquely human trait, like language and like making complex tools. It's also a highly social thing to do because we don't point when we're alone. Children with autism who have poorly developed social relationships also don't point to direct attention. They also have poor language skills. Now what I want to do is connect up pointing with language more directly. Well, language is also social. Both pointing and language require an understanding of triadic relationships. That's you, me, and the object I'm pointing to. Both pointing and language are connected developmentally. For instance, the age at which infants start attending to the mother's pointing can predict the extent of their vocabulary at 30 months of age. And both pointing and language are interchangeable to a certain degree. For instance, when we point to objects that are closer to us, we reduce the number of words we use. Okay, so what I want to do is sum it all up now. Primates are who they are because of snakes affecting their visual systems and making them different from other mammals that way. In addition, pointing to snakes in particular would have enabled us to point to other things, to share attention to those other things later on. And this would have given our bipedal hominin ancestors a direct survival advantage or benefit if we could point out those snakes. And if you combine this ability to point, to share direction, with a vocal communication system that was already well developed, then what I'm suggesting is that the two together could have combined to help open the door for the evolution of language and everything that came after that to make us who we are today. Thanks very much.